Hello everyone. This video will be very interesting and informative for those who want to learn about data warehouse. In this video I will try to cover all of important concepts of data warehouse. Once you complete watch this video, you can successfully pass any job interview related to data warehouse, and even you can start your career in data warehouse designing. So let's come back to the topic. So we will cover what is data warehouse, history of data warehouse, and goals of data warehouse, and what are benefit of data warehouse. And in the intermediate level we will cover what is operation data warehouse versus operation database versus data warehouse, OLTP versus OLAP. And now in advanced level we will cover data warehouse architecture, okay, principle of data warehouse, and what is operation data source. Data mart, you definitely heard and confused about what is data mart and data warehouse and data lake. So we will cover in this video what are these, and dimensional modeling and type of dimensional modeling. So let's start our actually uh, presentation about video. So what is data warehouse? Actually, data warehouse is nothing, it's simply a database management system, but the advantage of this, it's enable business intelligent activities. So I hope you understand my point that it is nothing but it's itself a data warehouse database system, and the objective is to create a business intelligent activity. Okay, data warehouse is also a relational database, as we create our SQL, Oracle databases. It's like that, it's not a new thing, but it actually include historical data, like we do not keep transaction system. Data warehouse is actually also integrate with different type of systems, like for our decision making. For example, I have a system, payroll management system, okay, in a Oracle, and mm, I have a sales management system in SQL server in backend. I am talking about backend, okay, not front end. Okay, so SQL server base our sales system. Maybe we have some data in our Excel files, which can be a manual system. For example, we are taking surveys from marketing team, getting surveys and put the survey in a Excel files. So these three or four type of systems we have. So what we mean here, integrate, that we fetch the data from all the sources which is required for our decision making system, okay, for our decision makers. So we push the data in data warehouse and create a report. So this is actually a difference between data warehouse and operation database, but we will discuss in later in upcoming slides. A data warehouse actually is not only for not for a particular group of user, it will for entire organization or entire department, maybe finance department, maybe your HR department, maybe your marketing department, maybe your sales department. So if we talk about entire organization, mean that all the functional department will be feedback or put into your organization, so they drive the organization goals. So data warehouse is similar like that. Okay, so keep in mind it's not a daily operation system like we do record a sales in a transaction system, like we do a patient care system, we do a daily input of the billing, caching, like that, but it's used for our decision making. Okay, so data warehouse has other capability, like it has a read only in read only intensive, because we once we push the data in data warehouse, we usually do not overwrite the data, but we take a read operation, we do run a queries to extract the data for our analytics purpose. Maybe they have a few large tables, like not traditional transaction system, but maybe have a few large tables, maybe one, maybe more than one, more than 10, depending on the size of your organization. So it supports relatively small number of client with relatively long interaction. Okay, okay. It include current and historical, as I told you, that prospective information. So a historical mean we can actually say that we have a 5-year historical data, 10-year historical data. So this type of historical data we can manage. Even we are also managing the changes of the data in data warehouse. Okay, the history of warehouse. History of data warehouse is actually the idea of data warehouse come to be the late 1980s when IBM researcher Barry Devil and Paul Murphy established the business data warehouse concept. So history is, if we say that history is not too old, actually it's just but now the things are getting evolving day by day. So data warehouse, data mart, data lake, and so things are going to be, and now we say that big data, the terminologies are coming very frequently, but the backbone of the thing is data warehouse. Okay, so in the absence of the data warehouse architecture, a vast amount of space was required to support multiple decision supporting environment. In a large corporation, it was ordinary for various decision support environment to operate independently. So what happened actually, everyone has their own copy of the data. Okay, they do, for example, finance department get the data from uh, IT team, and then they do their analysis. Sales department get their data from IT team and do their own analysis. So everyone doing their own analysis, or maybe someone has a data 3 months old, someone getting frequent data from IT, someone getting monthly based so these type of things actually creating a problem for management, CEO type people, like CTO, C executive type peoples, we can say. So that's why it's a gap. So in 1980s actually, Barry Devils and Paul Murphy established a business data warehouse concept. Okay, what is the goals of data warehouse concept? It will help to reporting as well as analysis, yes, obviously. Maintain the historical information, as I say, we can have a 5-year trends, 10-year trends, 15-year trend depending on the data, and it's create a foundation of decision making. So this is the goal of data warehouse. If any company wants to implement a data warehouse, so what is the objective is that they want to keep in mind these goals. If they are achieving these goals, that means this company may need a data warehouse. Benefit of data warehouse. What is the benefit of data warehouse? The benefit of data warehouse is understand business trend. You can develop KPIs, make better forecasting decision. Obviously, if you have a data and you have taking benefit of that, so you can take a forecasting, that for example next year what will be my sales, next current year what will be the my sale. So you can predict futures as well as seeing the current happening. For example, how many items are sold, what type of category of item are sold most frequently. Okay, what items are going to be expired, what item going to be ordered in the next month. So this type of things you can perform your data warehouse. Data warehouse are designed to perform well in numerous amount of data. Yeah, again, uh, it's not only for a small purpose of data, it's a huge amount of data. Now the term enormous is changed with the big data. Okay, the structured data was more accessible for end user. Okay, so structure should be very easy, understandable for the end user. So you can create a dimensional modeling or data modeling with this. Keep in mind that every end user can be used and take benefit from it. Query that would be complex in many normal data but easier to build. Yeah, I will go this explain in a next coming slide. So but the you need to be resolved, you know uh, if we talk about databases, then we have a multiple tables, and then if we have multiple tables, then we have a multiple joins. So it create a complexity to build a query. But in data warehouse we resolve these things. how, but I will explain in a later video, later slides. Data warehouse is an efficient method to manage demand of lot of information and lot of user. Okay, data warehouse provide the capability of a large amount of historical data. Yeah, we discussed this. Okay, so this is very important thing. Characteristic of data warehouse. If you know that is this are fulfill your data warehouse, so what are the characteristic of data warehouse? Subject oriented, it should be integrated, it should be time variant, it should be non-volatile. So let's discuss these one by one. Subject oriented mean, for example, we have a data warehouse and we have a operational application, like we have order processing system, consumer billing, claim processing, consumer loans, accounts receivable, like that. We have a many system can be in an organization. But data warehouse, for example, we have a finance, we have a marketing, like that. But data warehouse should be a subjective. Okay, so we say that we want to see sales, we want to see our customer, we want to see our policy. So it should be subjective, not, for example, in I will give you one other example. For example, in a patient care industry, we may have a 60 or 70 plus softwares, we have applications, we have, for example, radiology, we have billing, we have inpatient billing, we have outpatient billing, we have marketing, we have cardiology system, we have laboratory management system. So we have lot of system, but in the context of data warehouse, we are focused what subject we are talking about. We are talking about patient. So patient, inpatient, we are talking about cardiology, we are talking about laboratory. So this type of things, that warehouse, in warehouse we will not implement all the all the umbrellas of the organization. We will implement all the main subject of area. For them, finance data, for example, HR data. So these type of things are subjective. Integration, data warehouse integration mean various heterogeneous source like RDBMS, flat files, and online transaction record. It required performing data cleaning and integration during data warehouse. So what we need in actually, as I say, that saving account saving is developed in Oracle. Checking account is another system which is managing in SQL Server. Loan accounts will be in Excel file, flat file. So what we need, we actually extract the data in and load in our data warehouse. Once we load, maybe we need to perform some data cleaning. Okay, and for we need to, after killing the data, we need to load the data into our data warehouse. So it's also called a ETL process, extract, transform, and load process. ETL has a different subject, so I will not cover the ETL topic because it's a technical part of the thing. But understand that ETL is a process where we can extract the data from different sources and upload in our data warehouse, right? And once it's uploaded in our data warehouse, so we can use in our development of reports. Like we can attach any tool like Power BI, Tableau, Cognos, ClickView, or any other reporting tool we can use, or in-house tool we can develop a reporting. Even we can use our SQL server or Oracle database to extract the data, right? So integration is time variant. As name suggests, that time variant means historical information is kept in data warehouse. As I already talked, historical data in that data warehouse is maintain historical data. For example, one can retrieve file from last 3 months, 6 months, 12 months, or even previous data from warehouse. This variation with the transaction system, where often only the most current file is kept. So actually time variant is very important. So in data warehouse, this is a third characteristic of data warehouse, time variant. Non-volatile, yeah, this is another important thing. Data warehouse is physically separated data storage, which is transformed from the source, RDBMS. Yeah, so and the operational updates of the data do not occur in data warehouse. Yeah, so we will not keep operational updates in data warehouse. However, we keep the data. uh, for example, we have a any system, like for example claim system, insurance system. So what we are saying that, for example, claim, one transaction is going that we have a claim from any patient, then we say that this is a claim amount, $200 claim amount, and then we say that it's updated in a 1 hour after that, no, this should not be $200, it should be $150, because it's also already pay coupe for $50, so we don't have. And then we suddenly said that this insurance policy will be applied to this patient, not this. So 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 this is type of operation update. But in warehouse we will put exactly the not every transaction. We will put at the end of the day transaction in a claim insurance type example. So we will uh, make to decision what happened ultimately with this, uh, what is the amount of the claim. So we will say that its amount is $150 rather than $200. So we put $150 in data warehouse rather than a $200. But in operational system you may have a history maintained in like that. Okay, so this is non-volatile defined that once the data enter into the data and data should not be changed. Okay, so once 150 come in a data warehouse, it doesn't mean after 2 days you say that okay it will be changed into again $200, so it will not change. However, you can keep that, track the history of the data, that you can say that after 2 days that amount will be changed 150 to 200, so you can keep track of this, right? Okay, so next is what is operational database versus data warehouse. There is some significant difference between operational data warehouse and operational database. I hope you understand these concepts. uh, Operational database mean that we have a existing system in organization. Like I told you that we have a claims system, insurance system, radiology system, or for example marketing system, finance system, payroll system, accounts payable system. So these are all related with operational systems. So all these operation system must have a database. So operation system are designed to support high volume of transaction. Okay, what I mean that every seconds or minutes you have maybe hundred of transaction, maybe you have a thousand of transaction depending on the size of the structure. But in data warehouse we are talking about high volumes. Okay, so we have high volume in we have a high historical information like that. Operation system are usually concerned with current data and historical data. Okay, data with operation system are maintained update regularly according to the need. Yeah, that's you, I hope you understand. But in data warehouse it's a non-volatile. It is designed for real-time business application, but it is designed for business measured by subject area. As I told you, what is subject area mean, we have a focus on the data. We will not fetch all the data, we will fetch the data which we need to analyze. For example, we need to analyze sales data, or for example in sales, actually in a operational database we may have a 50 tables in the background, but in a data warehouse we may require a 4 tables or 3 tables. So we are talking about subjective areas, categories and attributes. It is optimized for simple set of transactions, generally adding or relative single row at a time per table. It is optimized for standing extend load and higher complex unpredictable queries that access many rows per table, right? So it is optimized for validation of information coming from during transaction, use validation data table, and data warehouse load with consistent valid information required. No real-time validation. Yeah, once we may need to fetch data either uh, or a specific frequency. Maybe we fetch the data from at every midnight, weekend, month basis, or maybe sometime after 4 hours every day or 2 hours every day periodically, but it's not a real time. Okay, it supports thousands of current concurrent employees or clients in the organization, but it supports few concurrent clients related to OLTP. Operation systems are widely process oriented. Data warehouse systems are widely subject oriented. So this is one of the key. Operational system are usually optimized to perform fast insert and update. Okay, but here in data warehouse we will not concern about insert and update. We will concern about to fetching the data, read only operation, data in, data out, large number of data access, large number of data access, both are similar in this scenario. Relational database are created for online transaction, OLTP, we called it OLTP. Operational database is also called OLTP, and data warehouse for also called OLAP. Okay, so what is OLTP versus OLAP characteristics? First, feature is characteristic. It is a system which is used to manage operation data warehouse, as we saw in previous slide. It is a system which is used to manage informational data, right? Okay, right, we it's a simple definition. Users, so it's have four characteristic features: characteristic, user, system orientation, and data content. So users, so it can be used any color, senior manager, manager, client, like that. But knowledge worker include managers, executive are usually who is a decision maker actually use OLAP. System orientation, okay, customer oriented base, but it's a subject oriented base. Okay, data content, OLAP system manage current data that too detail are used for decision making, OLTP. So OLAP system manage a large amount of historical data, provide facilities for summarizing, aggregation, store and manage at a different level of granularity. Granularity means detail of data. For example, we have let's say we have a customer data, customer order data. So order and order lines is our granularity. So but maybe for our decision making system or executive don't want to each order level, they want how many orders are going to be cancelled, how many orders are shipped, how many orders are pending. So they are focusing on the summarized level, aggregation level. Okay, so in OLAP we manage the data accordingly based on the requirement or subject, but in OLTP we are going to details. Okay, we will record each and every transaction of the order lines, or even we change history, we change the any amount of the quantity of the order, so we will keep record. But in OLAP we may not require for this. So again, continue with the OLTP versus OLAP database design. We develop ERD, but for OLAP we need to then dimensional modeling, which we call star schema or snowflake schema. We will cover star schema or snowflake schema in our upcoming slide in this video, so don't worry about that. Views, OLTP system focus primarily on the current uh, data within the enterprise or department without referring to historical information of data. Okay, so OLAP system often span multiple versions of the database schema due to the evolutionary process, and OLAP also deal with the data that originate from various organizations dealing information from many data stores. Okay, volume of data not very huge, but here it's huge. Access of pattern, so access of pattern of OLAP system subsist mainly of short atomic transaction, but access of OLAP system mostly read only method because of the data warehouse store historical data. Access mode read write, but mostly write. We will write data, okay, in this case, right? Insert and update, number of record access 10, and the millions of record access. We may need one air transactions, so we need millions of code. Normalization, fully normalized, partial normalized. We will discuss what is normalized in upcoming slides. Processing speed fast, yeah, it should be fast, because if while you are reserving any order, so you need to be a quick response time. But in OLAP, it may depend on the, you know, the query or data size of the record. Maybe it can be take 1 minute, 2 minute, depend 30 second, few seconds, depending on the system. So it's a very important part, because sometimes users say that your dashboard should be a just once I click it should be report, the dashboard should populate the data. So it's not really the case in OLAP. It should be a case in a, you know, OLTP, but in a OLAP it should not be a case. You need to actually analyze the data. You may process any aggregation calculation, so it's performing something. So your dashboard may need 5 second or few second, or maybe up to 1 minute or 2 minute, depending on the load of the or complexity of the queries, so it can refresh your data or populate your data on your dashboard. Okay, so the very important topic, and it's going to be a bit advanced topic, that data warehouse architecture. But it's not a very complex, and mostly I would like to say that mostly the job interview, if you are going to make a career in data warehouse, so this type of questions comes in a job interview. Usually people ask that what is data warehouse architecture. So it is a method of defining the overall architecture of data communication process and presenting the axis of client computing within the enterprise. Okay, each data warehouse is different, but all of the characteristic of vital components. So there are three types of architecture: in basic, with staging area, and with staging area and data mart. So let's come with the basic architecture. It's a very pretty simple actually architecture. Architecture is not a complex thing, but you need to understand that. For example, we have system 1, system 2, system 3, or we have a flat file. So what we do, we load this data using a ETL tool in a data mart, or maybe a data warehouse, we can say. Okay, actually data mart, I will cover data mart and data warehouse, which is actually interchangeable, but there is different. Data mart is specifically for any department level data. For example, in organization we have a 5 department: HR, finance, marketing, sales, or maybe call center department or feedback department. So we can develop data mart for each department, or we can develop a data warehouse which is combination of the, you know, all the source systems like finance, marketing, sales, and call center, like that. So we can develop a data warehouse on over the top of the data mart. So we in data warehouse we have a data structure, metadata, summarized data, raw data. So all the things gathered in a warehouse, and then we create a report for user, for our analytics, reporting, data mining. So this is our output track. So this is very basic structure, right? So data warehouse with staging area. What happened in data warehouse with staging area? We have again same data source. Operational data could be a one system, two system, three system. We have maybe a manual files, flat files. Then again, using ETL, we store the data in our separate staging area. Okay, and once we store the staging area, then we push the data in our data warehouse. So after transformation, applying some transformation. Okay, so the same user analytics, output, and mining, where we can use our this data warehouse. Okay, so data warehouse architecture with staging area and data mart. And what happened in data, it's the same. We have a data source, operation system, system 1, system 2, manual files, flat file, text file, JSON file, could be a APIs, and then we have a staging area here. Okay, then we write ETLs here. Okay, so once we write ETLs, so it will push the data in our data warehouse. then we may have a purchase department which actually taking benefit from our data warehouse, and then we have a sales department, we are taking benefit from our this data warehouse, then we have inventory department. So once each department will use their own data from data warehouse, then they can use for analytics purpose, reporting purpose, or mining purpose, like that. So this is a different three type approach. Usually this type of approach is usually used mostly nowadays, but you can develop any approach architecture. The properties of data warehouse. So this is another question which people ask, that what is the properties of data warehouse. So data warehouse actually is a separation, scalability, extensibility, security, and administrability. So separation, analytics, and transaction process should be kept apart as much as possible. I hope you understand this point, because once we have a transaction system and analytical system, so in we keep apart from as much as possible. So this is our properties of data warehouse. Scalability, yes, we can whenever we need to increase our size of the space, or we need to size of the memory, we need to increase our memory, so it should be scalable. In terms of software and architecture, both should be scalable. Architecture should be able to perform new operation and technologies without redesigning the whole system, right? So this is one of the important points. Security, yeah, security should be very important, because if you have a data, confidential data, then and it's restricted to finance department, then only finance department will able to like for example, here you have a purchasing data and it's only restricted to purchasing department data. So your purchasing department will only extract the data from sales department, will not see purchase data. Or if you have a finance department, then they will not, the other department will not see their data. If they are able to see, which mean their your database is not secure. And administrability, data warehouse management should not be complicated. So it should not be complicated that everyone got confused where I can fetch the data, where is the sales data, where is the purchasing data. So it should be managed in a simple way, which can be managed easily. So type of data warehouse architecture, there are many, mainly three type of database architecture. Okay, single tier architecture, two tier architecture, and three tier architecture. Let's discuss three tier, because it's mostly or commonly used nowadays, three tier architecture. So what is three tier architecture? Data warehouse usually have three levels architecture. Bottom tier, where we have an actual physical server, data warehouse server. Middle tier, we have a OLAP server, which we call cube server. And front end, where we have a BI tool like Tableau, Power BI, or any reporting tool like SSRS, or you can say Crystal report. So these are come in the top layer. So middle layer could be cover SSAS, any cube tool like Talent Cube, or Data Integrator, or Cube Designer, or Workbench, we can say, or SSAS. Or in bottom tier, we have a physical data warehouse like in Oracle, SQL, we can say. So this is actually one of the examples of three tier architecture, that we have operational data, we have external file data, then we write a ETL tool. We may have a reconciliation layer, but it's optional, but it's good if we have a reconciliation real layer on the data, that for example, how much records in a data warehouse has been updated, and how much record are in the operation data. So what is the gaps? Actually reconciliation data mean make sure that how much gaps we have, or if we don't have any gaps, so it will make sure that our data is populating on a regular basis or correctly. So once we do ETL data, so it will push the data in data warehouse, and then we may have a data mart layer, but it's optional again, I would say, as we saw in a basic or uh, you know uh, in a previous slide we saw basic architecture, and with staging area we saw that we don't have a data mart. But as I told you that this architecture is commonly used nowadays, so people try to take benefit of data mart. So data warehouse may feed data mart, and data mart will be used for our reporting, data mining, what if analysis, like that. So this is actually a source layer, then we have a staging layer, then we can reconcile data, loading, data warehousing layer, and then we have analyzing layer. So this type of things we are actually three-tier database architecture. So principle of data warehouse is again not a rocket science. Load performance, load processing, data quality, query performing, and terabyte scalability. Okay, so this is type of thing that our data warehouse should be able to load performance, handle the load in term of performance and processing. It should be a data should be in a good quality, so we can take benefit of our analyzing or analysis or decision making. For example, in data we have a garbage data, so we need to clean the data first. For example, zip code are missing, or maybe area of city is missing, country is missing, so in this case we will not getting the correct geographical information or analytics if we are missing. For example, in sales amount, most of the amounts are going to be null, so it will create a mess. So we will need to manage the data quality first, and then we are focusing on query performance, or it should be data warehouse going to maybe going to be a terabyte level, so it should be scalable to at this level. So this is the principle of the data warehouse. Once you're designing, or keep in mind that these principles should fulfill while you're designing the data warehouse. Okay, so what is ODS? ODS is actually described by in Mon and in Mohoff in 1996, a subject-oriented integrated violated current data store. It's similar like a data warehouse, but this is a different current value data store. As we see that in data warehouse we have a subject-oriented, integrated, time-oriented, and non-violated, but here we have violated and current oriented. So this is different. ODS has a current value, that ODS is up to date data following the current state of data. Actually, let me say that what actually ODS do. Like we see in our previous slide, staging, like we see staging. So staging can be part of the ODS. We can say we read the data from operation system, then put the current state of the data in our staging, because we don't want to every time hit our transaction system. If we do hit our transaction system, that it may be degrade the performance of the operation system. So what we do, we fetch the data after 4 hours, 3 hours, depending on maybe on a day end or weekly basis, monthly basis, depending on the nature of the data fetching. So we put in our staging data, and then we perform all the analytics, I mean transformations, and then we put transformation and then put the data in data warehouse. So ODS is like this. So in ODS we do this type of things. This ODS frequently change and new refresh the data. Okay, so in ODS we have a detailed data, but in warehouse we do where aggregated data. Okay, so ODS versus data warehouse, there are some difference. ODS mean for operational reporting and support for current or near real time, but in a data warehouse, historical trend and usually for large data. So ODS consists of any short window of data. Okay, it is typically detailed data only, and it is summarized and detailed data. It can contain both data It is used for detailed decision making and operation report. It is for operational level. Itself conducts a data between operation and analytics. So it can be used for operation and analytics system, but it will not maintain historical data, but it has a cleans data, as I told you, that clean and consolidated data. So it is updated often as the transaction system generate new data. Okay, and it is batch processing or scheduled data. So what is data mart? Data mart, actually this slide is come very late, I am sorry for that, but I already explained that for our we have a data warehouse and we have a different department like finance department. Okay, we have a billing department, we have a marketing department. So this data was for this for billing, this for marketing. So these are for department level things. Okay, I hope I will explain earlier to you. So this is our department level things, right? So reason for creating a data warehouse, excuse me, create collectively data by group of people. So we can say that the group of finance people can see this data mart, can access, so they will not able to see billing. So billing and marketing data will be secure from that. So easy access for frequent data needed. Again, they are concerned about their finance, people concerned about finance data, so they can easily accessible and fetching their finance data without affecting the billing and performance of the marketing data. Ease of creation, again improve user and response time, definitely lower cost, and potential client are more clearly defined and comprehensive data warehouse. It contains only essential business data that is less cluttered. Okay, I hope you understand these points. Type of data marts. There are two type of data mart: dependent data mart and independent data mart. So dependent data mart, actually, as picture show, it has a, again, flat files. We may have a flat file. It's not necessary that every system has a flat files or API files or ODF files. We may have an external system where we can talk about Amazon, Amazon store, or maybe any Google sheet. So we, in this case, we have external data, we call it. So ETL is a process which feed our data in data warehouse, and then we create a marketing data, sales data, finance data warehouse, as we talked about earlier. And independent data, actually, so it is a dependent, so it's a dependent, right? It's a dependent of, actually, what, on data warehouse, but it's an independent data mart. We may have external files, but here we don't have any data warehouse, so it's directly feed our sales of marketing data mart, right? So we may have these two approach, right? Okay, so data warehouse versus data mart. So data warehouse is a very is a vast repository of information collection. So data, as name suggests, data warehouse contain huge set of data. It contain marketing data, sales data, human resource data, finance, billing data. But in data warehouse we have a specific subject data, specific department data. Okay, it hold multiple subject area. Yes, it hold very detailed area. It hold more summarized data. Work to integrate all data sources or integrate with given subject area. For example, this is our this has a marketing data or maybe sales data, so it has sales or marketing data warehouse. It may not has a flat file system, it may not has a marketing or finance file system, so depend on that. Fact constellation is used. Okay, so in this case, and data mart schema snowflake is used. So we will I will explain what is this in upcoming slides. It is centralized or it is decentralized. Data warehouse is a data oriented, is a project oriented. Yes, this is very good point, it is mentioned, project oriented we can say. And what is, so now we come another important point topic, that what is dimensional modeling. So I would say if we have around to cover most of the topics. So if you uh, did not understand anything, so you can comment on the video as well, but I would suggest that you can stop this video here, you can go through and rewind the video and watch again which concept you did not understand. You can take benefit from other sources as well. So let's begin with our very important topic of this presentation. What is dimensional modeling? Actually, dimensional modeling is objective is to present a data for our cube operation. Okay, so the founder of dimensional modeling, Kimball, and they introduce a fact and dimensional tables technique. So what are fact and dimensional table? We will discuss in our upcoming slides. So but the dimensional modeling, the transaction record divided into either facts, which are frequently numerical transactions, or data dimension, which are the reference information that give in context to the fact. The purpose of dimensional modelings are to produce database architecture that is easy for front-end clients understand and write queries. What it means that we can remove the complexity of the queries, we can remove the complexity of the database. Okay, so it should be a fast access and simple to use. To maximize the efficiency of query, it achieves the goal by minimize the number of tables and relationship between them. Okay, the element of dimensional modeling. So fact, it is a collection of associated data item, consists of major and context data. It is typically represent business item or business transaction. Dimensions, it is a collection of data which describe one of business dimension. Dimension decide the contextual background of the fact, and they are the framework over which overlap is performed. Measures. So measure, it's a numerical attribute of fact representing the performance or behavior of the business related to the dimension. So let me actually explain this in a actual data warehouse which we have in SQL Server. So we have a AdventureWorks data warehouse. This example is available on internet. You can download it and attach with your SQL Server instance. So it is a very good example. So where we have a dimension table, and dim represent dimensional table, fact represent fact table. So for example, we have a dim date. Let me show what we have in a dim date. So dim date actually has one record. It's of every date. For example, we have a date start from 2005 0102. We have a date from 0102 0103 0104. So first of Jan, first 4th Jan, 5th Jan, 6th Jan. So we have a key which is our, we call a unique key. Although it's a unique, but we in data warehouse or dimensional modeling we manage a unique key. Then we have what is a day of the week, Saturday, Sunday, so all other related attributes. This is calendar year, like this. So this is a dimensional view where we have perspective of data. For example, if we want to see year 2005 data, so we will join this dimensional table with, for example, fact reseller or internet sale table. What we have in a fact table, like, okay, so oh, I'm sorry for that. So fact table, actually give me a sample of your fact table. Fact table again has a product key, not product name here. 310 has a product key. So this product key has a associative record in this dimensional table. Order key, order date key, we already see that date key, this date key will be joined with date key, due date, ship date, and again date key, customer key. So in this case, actually these are the numeric value. But what is measure? Measure is here unit price, extended volume. So calculation, where we perform a calculation sales amount. So what we want to see? We want to see the, for example, I would say that we want to see that product 310 has how many sales in a year. So product and year is a dimension, and sale comes from fact table, it's a measure. So this type of concept, I would say, that will be covered here in a definition. So fact is a collection of associated data item, like we have a consists of measure and context data, as I show in a fact table. Dimension data we describe one business dimension, and numeric attribute of fact is called a measure. I hope you understand this thing. And what is multi-dimensional data modeling? A multi-dimensional model view data in the form of data cube. A data cube enable data to be modeled and view multiple dimension. So we have a two type of data representation, tabular and multi-dimensional. Tabular is like a table form, that for example we say PID, for example policy ID, time ID, location ID, sales ID. So we have this type of thing, or maybe personal ID I can say. So 11, so we can see this. But in multi-dimension we have rubric cube type data, 3D view of data. Okay, we can say this is a personal ID 11, 11 had 25 combination, time ID. So this is three-dimensional view of data. So this is a difference between so data cube actually a three-dimensional view of data. Okay, so this is our data cube. Again I will just go in a data cube, so 3D view. Okay, so we have a this view, then this view, and then this type of view. So three type of view based on location, where we have a location here, we have a time here, we have a product here, like that. Star schema, so this is one of the most fundamental concept of dimensional modeling. Actually star schema is the element form of dimensional modeling. If you someone asks that what type of dimensional modeling you can do, you can say that we can do star schema, snowflake schema. Okay, and there is one third one which I will cover in upcoming slide. So mostly star schema will use in Power BI, tool like Tableau, tool like other ClickView. We will do star schema modeling, so they will give a proper or appropriate result. So what happened is star schema. For example, we have a fact table, and each fact table may have multiple dimensions, but each dimension table will be talk to the fact table like we did. Okay, so this is star schema. So I hope you understand this thing. Let me come like this. So for example, we have this is our fact table. Okay, and its fact table name is fact internet sales. Okay, and then we have a relation with product table. So what I would say here, I would say here, so this is our product table, this is our fact internet sale, then we have a product table, then we have a date table. Okay, order date table, then we have a ship date table here, and similarly customer table. So I would say that this would be customer table. So all these are relation is no dimensional table to no there is no direct join between dimensional table to dimensional table. This will be not a join here. So these all join will be linked one to one to many join with the fact table. Characteristic of a star schema. The star schema is intensely suitable for data warehouse design because of the following feature. It creates denormalized databases that can quickly provide query response. Yes. It provides a flexible design that can be changed easily, added throughout the development life cycle as the database grows. It provides a parallel to design how end user typically think of the use of data. It reduces the complexity of metadata for both developer and end user. So let me come back here. So you know that we know that product key mean we have a dim table product key, we have order date, which mean we have a dim date table here like we have in above. Then we have a customer key, so we have a customer table. So this create a very simple structure. Okay, so it's reduce all the complexity. Also we just know that for product key we need to join this very simple join. For customer key, if we want to know how many customer we have or what is the detail of 14501, let's me go like this. For example, we have a customer where customer key is equal to 14051, I think so. This is, yeah, so this is our customer. His name is Nathiel, last name is Rivera. So her date of birth is this. So sorry, this is not her, this is male. Gender, okay, then its email address is like this. So we can get the information once we join. We can get the more attributes and more information from this table using joins. Okay, so snowflake, in snowflake actually snowflake schema known as snowflake if one of the more dimension table do not connect directly to the fact but most join through our dimension table. So in star schema all the dimensional table connect directly with the fact table, but in snowflake schema not necessarily all the dimensional table directly connected with the fact table. So in this case this dimensional table connected with the this dimensional table or this. For example, I will give you example of country. So fact table connect with the city table, like then I will say I will use like other color, and a region connect with region, then country, so for example this is connect with country, this is connect with this is connect with this. So this is type of hierarchy we are maintaining in snowflake. So star versus snowflake. Star dimension represented by one table, dimension are expand into multiple tables. Okay, fact table surrounded by dimensional table, less join or required many join. Yes, definitely. So in this case if we need to reach this table, for we need to join this and then join this table to this and this table to this, so we need to more joins in snowflake. So it create a bit complex design. It's more usually a normalized form, but it do normalized form. Why we don't care denormalization? Nowadays we know that space is not an big issue and space is going to be cheaper and cheaper day by day. So in this case we are not worried about the space, we are worried about the performance of the queries or performance of the data. So high level of data redundancy. Yes, if data is denormalized then data should be redundant. In this case data is not redundant. Maintenance is easy maintenance is difficult. Why he said that in this case maintenance is easier maintenance? Because it's close to our ERD or OLTP system, so its maintenance is easy. But this case we need to manage keys and joins, like to reduce the complexity, like we do in this case, that for example we have fact table, then we need keys of this product key. Rather than put a product ID, we have to manage something like that. So it's just type of create a bit complexity, but in the long term it has a benefit. Okay, so good core, good for man to many relationship. So there is third one approach, fact constellation schema. If fact constellation mean two or more fact table sharing one or more dimension, it is also called Glassky schema. So what happened actually? We have a fact table and we have fact table 2. So if in this case actually these both fact table need to join. For example, this is order and order line table, but in this case we need to join. So if this is the case, then we are called is a galaxy schema or fact constellation schema. But ideally we need to avoid this. We need to avoid in our modeling. If this type of scenario come, we need to create something like in between associative table or bridge table, we can say, to reduce this problem in our data warehouse. Dimensional modeling, continue with the dimensional modeling. So we have a fact table, we have a dimension table. Dimension table contains set of dimension of fact, contains fact of foreign key. So I already explained you in a demo that what are the dimension table and what are the fact table. So this is actually a business process, how we gather the requirement for data warehouse. For example, you're working on a data warehouse project, then what you need to do, you need to select the business process requirement, why we are going to create a data warehouse, declare the grain, how much detail we need actually. For example, we need to usually put aggregation in a data warehouse, but sometime we may need to go each line by line detail of the record. So how much we need to identify the dimension, that what are the dimension, patients, employee, department, date, time. These are the most commonly used dimension. Identify what we need to do, what we need output, okay, and then build the schema. I also identify what is the measures, okay, what we need to view, like sales, yearly quantity, yearly internet sales, yearly sales by gender, yearly sales by age group. So these type of things we analyze in this scenario. So again come to the rules of dimensional modeling. Load atomic data into dimensional structure. Because I am reading this because it's a simple definition. If you understand the below concepts as I described till now, so you don't need to remember this thing, just read it and you will understand this concept clearly. Build dimensional modeling around business processes. So this is a business process what I explain you. Need to ensure that every fact table has associated date dimensional table. Ensure that all fact in a single table that are the same grain or detail level. Granularity, we discussed the granularity here. Okay, it is essential to store, report, label or filter domain value in dimensional table. For example, what I mean to say, it's again simple thing, but I am going to recall you. For example, I would say that in this table we have a customer key, but we don't have a gender. If we want to say how many males are buying this product, so first from this key we need to go customer table and then we pick gender from here, or maybe age we can pick here. We can also pick if someone yearly income is like greater than this, so he is going to buy this product. His education is bachelor's, like so all the other relevant attributes comes or maintain in a dimension way, but in fact we maintain what we want to see and how we want to see. Okay, so need to ensure the dimension table use a surrogate key. Yeah, surrogate key is a key actually over the top of the our, for example, this is customer keys over surrogate key. Okay, however we may have a system key or which is called primary key AW001401, but we have a surrogate key. If 1045, if 14051 comes a second time with, for example, is changing the record with the date of birth is different. For example, we can say its date of birth is not 1982, it's 1981, and we create another record in this table, so its surrogate key or customer key will be changed. It could be a 19051, not necessary 14051, it could be, so it will keep two record, 14051 and 19051. So it's, this is called a slow changing dimension. We will discuss slow changing dimensional in next upcoming slides, so don't worry about that. Type of dimension, we have confirmed dimensions, outreach dimension, shrunken dimension, role playing dimension, junk dimension, degenerative dimension, swap dimension, and step dimension. These are the most important dimension. Let me say that I would say confirmed dimension is most important, role playing dimension is more important, it's almost used. Junk dimension, degenerative dimensions. So these three or four are very important dimension which you need to understand and develop your skills in it. Confirmed dimension, confirmed dimension actually is the case, let me show in a practical way. For example, we have a customer dimension, so this customer dimension, or I would say date dimension, date dimension is a very good example. So date dimension is a dimension which not only use in the fact internet sale, it may also use in a reseller sales, another fact dimension. Let me show like this. Okay, fact reseller sale. So let me open one more thing for your easiness, paintbrush. I will show you what I want to say. Okay, for example, I have a date dimension here. This is my date dimension, time date, and I have one fact, two fact. So I would say that this is fact table 1, and I would say fact table 2. So what confirmed dimension is doing, this date dimension actually sharing with these two tables. So this is confirmed dimension. So date dimension is our confirmed dimension because it is utilizing or using in a fact table 1 and fact table 2, right? So I hope you understand this thing. So if we have a date column across many fact, we could say that date is a key in all tables. So degenerative dimension is without corresponding dimension stored in a fact. So sometime what we need, for example, I would go in a fact table, like this is our fact table, and someone say, oh, I need a sales order as a dimension. So in this case we don't have any dimension of sales order. Okay, so what we say that, what we do in this case, we will say select distinct sales of, for example, let me take this from this distinct sales order let me run this. So this is our actually distinct record. So in this case 3796 records are distinct. So this is our G degenerated dimension in this case. Okay, so this is order date, product key. So order key in this case will be the, so junk dimension, what we have happened, what we do in junk dimension, it is used to reduce the number of dimension low coordinately. For example, we have a color, car, body, we have three dimensions table. If we want to reduce, and this is designed without junk dimension, if we want to create a junk dimension, what we use, we create a another car attribute. Car attribute contains color, body. Okay, so this will create a one dimension based on color and body. So these two dimension comes under in a car attribute, and then car attribute itself a car attribute id. Okay, so this id we use here, and car attribute id is a this id, like this. So it actually reduces, so we can reduce as many as other dimension if we need, right? Role playing dimension, this is another very good example. So I will again go in a uh, let me show like this. So first I will go you share you like this. So we have a order date here, due date here, and ship date here. We have a three dates here: order date, maybe other date as well, but for the sake of example, order date, due date, ship date. But we don't have a table like dim date, dim ship date, dim due date, dim ship. So we don't need, because we have a dim date. So dim date will be playing a three role here. Dim date work as a order date, dim date work will be the due date, dim date work here ship date. So how we can model it? For example, we have a dim date, and we have a this three keys. So what I would say, ship date, okay, and then we have a dim date, so due date, and finally we have order date. So let me go create a relation. So in this case, dim date will be act ship date. In this case, dim date will be work as a due date. So same dimension will be act as a three different roles: ship date, due date, order date. So this is called a role playing dimension, like, right? Slowly changing dimension, this is a very good concept actually. Again, it is a dimension which change over time. As I told you that in my previous example, for example, we have a customer whose last name is going to change, or maybe his geographical key is changed from 31 to 32. So we have in this case three or four options. Either we can overwrite 31 to with 32 and do not create a new record, historical record, one option. Okay, so this is called type 1 history. Type 0 mean we don't change current record. So type 0 mean we will not changing anything, it will remain 31. But if we are change 31 to 32, so this is our type 1, we are overwriting this. Type 2 mean we are updating 31 to 32 but also keep maintain 31 as well. So in this case we are creating another record like 31 to 32 with new customer key. It could be a 1 140 rather than 19051, could be any key but with 32 records. So we are maintaining a record 14051 with 31, then we have 32. So this is our history maintained, how it's history maintained, right? So type 3 hybrid, only the last chain and current value is stored. Okay, and type 4 we split data into two tables, first current record and second record, most commonly chain. So this is our thing. So sometimes we also maintain current value. This is our old value, this is our current value. So if we want to know that what is the current value of this uh, customer, so we can get, we filter the record with the current value and then we can get the value of 32 geographical key. So this is how we can manage our slow changing dimension. And finally we are done with the QA session. I hope you understand the basics concept, but I would say it's not a basic concept, but if you do not understand anything, or if you have any question answer, do comment on this video below, so I would like to answer your questions. And I know that it's a long theoretical session, and but I would suggest that it's a core concept of data warehouse. If you want to make excel your career in your data warehouse, then you will go through this video by one, step by step, slowly, and progressively, uh, and understand this concept. However, you can also find many important topics of the data warehouse, or all the topics of the data warehouse, which I covered in internet as well. So thank you very much for watching this video. I hope it will help you, and best of luck for your future data warehouse architecture. Thank you. Bye.